Okay, so today we learned about chemical formulas and how to read them. So, chemical formulas look like this, and this whole thing is a chemical equation. So this is the chemical equation for photosynthesis. So this chemical equation has 1, 2, 3, 4 chemical formulas, each for a different molecule. Here's another example of a chemical formula. And then this shows us a reaction with the reaction sentence, the chemical formulas for each of the molecules, and a diagram of what they look like. So the first word you need to know is chemical symbol. That is the letter or letters that stand for the element. So that tells us the element. Now, chemical symbols always start with a capital letter. As you can see over here, here's a little part of the periodic table. Every one of these starts with a capital letter. And if it has two letters, the second one is always lowercase. So that way we can put them together in a word, so to speak, in a formula. And we'll know when one chemical symbol ends and the next one starts, because the next one always starts with a capital letter. So if they're next to each other like this, we know that these are two different elements. There's S for sulfur and O for oxygen, and it's not SO because otherwise the O would be lowercase. Then we have subscripts. So subscripts are these numbers that come after the letters that are lower down and smaller. That tells us how many atoms there are of that element in the molecule, okay? So this has 2 sodium atoms because it's Na, which is sodium 2. Na2 means 2 sodium atoms. Over here, we can really see what that looks like because we have CH4. So that would be 1 carbon, that's the black one, and then 4 H's, 1, 2, 3, 4 of these white ones, 4 H's, CH4. These molecules are just O2 because they're 2 oxygens, O2. This one is CO2, so that means there's 2 oxygens again. So there's 1 C, that's the black one, and then there's 2 red O's over here. And then H2O means 2 H's, which would be these white ones, and 1 O, which is the red one. So again, subscripts, these little numbers, tell us how many atoms of that element. So 4 atoms of hydrogen in this molecule, 2 atoms of oxygen in this molecule, etc. Then we have another number, which is a coefficient. This is the larger, the full-size number that's always out in front of a molecule, and this tells us how many of that molecule. It's just like in math when you have a number in front of a variable like x, and it tells us that we're multiplying that number by x. Well, similarly, we're multiplying this molecule by 6. We're multiplying this water molecule by 6, and we're multiplying this oxygen molecule by 6. So here's one way, here's a model that shows that. We have 2 O2s. Well, that's 1 molecule of O2 and another molecule of O2. And over here, we have 2 H2Os. So that's 2 whole separate molecules of H2O. So check this one out. We have Na2SO4. So in this chemical formula, we have 3 elements, Na, S, and O. So to find elements, all you have to do is count the number of capital letters that you see in a chemical formula. So Na has 1, S has 1, O has 1. So that's 3 elements. Now, how many atoms are there is a little bit trickier. So for atoms, we add up the subscripts, and if there's any chemical symbol, if there's any element that does not have a number after it, we count it as 1. So this is 2 plus 1, that's 3, plus 4, that's 7. So this one has 7 atoms. So I'll show that again. 2 plus 1 plus 4. There's 7 atoms in this. Okay, so maybe let's try CH4. So there's C with no number, so that's 1. And then H has a 4, so that's 5. 1, 2, 3, 4, 5. This chemical formula has 5 atoms, but only 2 elements because there's 2 capital letters. Okay, so let's take this and let's apply it in our activity called, let's see, we're in module 18. We're going to do the activity called Chemical Formulas Practice. All right, so this is down at the bottom, 12 points. So let's try a couple of these. So for each of these questions, I gave you the chemical formula, but also I gave you a picture to help you. So this is FES. Notice the E is lowercase. So number of elements. So looking at the formula, you can count the capital letters. So F is 1 and S is another, so that's 2. And looking at the model, you can count the different colors you see. So we have purple and white. So that is 2 elements. What about the number of atoms? Well, for this, we count the subscripts, but there are no subscripts. So each of these elements has 1 atom, and we can see that clearly in the model, 1 and 1. So there's 2 atoms in this. Now, each of these questions has a follow-up question, which is this a molecule, a compound, or both? So a molecule means it has 2 atoms stuck together. It's a molecule. A compound means it has different elements in that molecule, and it does, so that's a molecule, which means it's both. Let's do the next one. So this is the chemical formula N2. So N is the only symbol in here, so that would mean we have 1 element, and number of atoms, well, we have 1 subscript to count, and that's 2. And that matches up with the diagram because we have 1 color, so that's 1 element, and we have 2 atoms, which is 2 atoms. So is this a molecule, compound, or both? So it's a molecule because it has 2 atoms in it. Is it a compound? Does it have different elements in it? No. So it's not a compound, it's not both, it's just a molecule. So I hope that was helpful with helping you get started with that. Thanks for watching. See you next time.